Assalamualaikum warahmatullahi wabarakatuh. Today we are going to explain to you about differentiation, and we are going to answer some questions related to differentiation. Differentiation is a method used to measure a big group of functions more efficiently. Other than that, differentiation is the second chapter out of 5 chapters that we learn in Calculus 1. Under differentiation, there is 5 topics that we will learn. The first one is the first principle, the second one is the rules of differentiation, the third one is implicit differentiation, the fourth one is the high order differentiation, and the last one is linear approximation and differentials.
Differentiation allows us to find rates of change. For an example, it allows us to find rates of change of velocity with respect to time, which is acceleration. Related rate is problem that involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rate of change are known. Differentiation with respect to time or one of the other variables requires application of chain rule, since most problems involve several variables.
Hi, Assalamualaikum. My name is Nur Salma, and let's start with question number 2. Question number 2 states, a hemispherical bowl contains liquid as shown in figure 6. The volume of liquid is given by V equals to pi over 3 H squared open bracket 24 minus H close bracket, where H is the greatest depth of the liquid in centimeter. If the liquid is poured into the bowl at the rate of 100 centimeter cube per second, at what rate is the greatest depth of liquid increased when it is 2 centimeter? Okay, so in the question points out the volume of liquid, and the liquid poured at a rate 100 centimeter cube per second. Means dV over dt, because centimeter cube refers to volume and second refers to time. The question asks, what rate is the greatest depth of liquid increasing when it is 2 cm? Means dH over dt, because greatest depth refer to H and rate is over time. So how to get dH over dt? First, we start with volume. Volume here, V equals to pi over 3 H squared open bracket 24 minus H close bracket. We need to elaborate first. It will become 24 pi over 3 H squared minus pi over 3 H cube. Next, we need to differentiate volume. How? We bring 2 to the front and the power will minus to 1. So it will become 2 times 24 pi become 48 pi. We divide by 3, it will become 16 pi H. Over here, 3 brings to the front and 3 divide 3, we simplify becomes 1. So we get the equation dV over dt equals to 16 pi H minus pi H squared. Then we differentiate both sides using implicit differentiation. It will become dV over dt equals to 16 pi H minus pi H squared dH over dt. We know that dV over dt is 100 and H is 2. So we just need to replace the values into the equation. So 100 equals to 16 pi times 2 minus pi 2 squared dH over dt. 32 pi minus 4 pi is 28 pi. 28 pi brings to the left, and 100 divide 28 pi. We need to simplify to get the answer of dH over dt. So the answer is 25 over 7 pi centimeter per second, or 1.1368 centimeter per second.
Moving on to the next question. This question is from past year paper September 2014. Question 3b. Consider the function fx equals to x times 8 minus 4x squared. Number 1, find the x-intercept and the y-intercepts. Number 2, find the intervals where the function fx is increasing or decreasing. Hence, determine the extremum point. Number 3, find the intervals where the function is concave up or concave down. Hence, determine the inflection point if any. Number 4, sketch the graph of fx using the above information. Question 1. Find the x-intercept and the y-intercepts. For x-intercept, we must make our y or fx equals to 0. From this equation, we can just substitute 0 into fx. Then we will get 0 equals to x times 8 minus 4x squared. Next, we just expand the equation. We will get x equals to 0 and x equals to 2. Therefore, the x-intercept is 0, 0 and 2, 0. Moving on to y-intercepts. We must first make our x equals to 0. First, we expand the original equation. Then, we will get y or fx equals to 64x plus 16x cubed minus 64x squared. Then, we just substitute the 0 to the x. We will get y equals to 0. Therefore, the y-intercept is 0, 0. Second question, find the intervals where the function is increasing or decreasing. Hence, determine the extremum points. To find the intervals where the function is increasing or decreasing, we must differentiate the fx. From this equation, we know that we can use product rules. First, we find x. Then we differentiate x, then we get u prime equals to 1. Next, we find v. Here, v equals to 8 minus 4x squared. Then we differentiate 8 minus 4x squared. Firstly, we bring the power 2 to the front. Then we copy down 8 minus 4x. Then we differentiate 8 minus 4x and we will get negative 4. Therefore, we will get v prime equals to 32x minus 64. Now, we use the equation f prime x equals to vu prime plus ub prime. Then, we just substitute the u prime, v and v prime into the equation. The next step, we are going to expand the equation and we get f prime x equals to 48x squared minus 128x plus 64. Then we get x equals to 2 and x equals to 2 over 3. Next step, we're going to draw a table consisting of 3 intervals which are negative infinity to 2 over 3, 2 over 3 to 2, and 2 to infinity. We use 0 as the test value for the intervals negative infinity to 2 over 3 and 1 for the test value to 2 over 3 to 2. And 3 as the test value for the intervals 2 to infinity. Next, we substitute the test value into the equation of f prime x. For 0, we will get positive sign. For 1, we will get negative sign. And for 3, we get positive sign. If the sign is positive, it means the slope is increasing. So we draw an increasing slope like this. If the sign is negative, it means the slope is decreasing. So we draw a decreasing slope like this. Same goes to the test value 3 that we got. The sign is positive. It means the slope is increasing. From the slide before, we know that the factors for fx is x equals to 2 and x equals to 2 over 3. From there, we can determine the extremum point. How? First, when x equals to 2, we can substitute 2 into the fx. Y equals to f2 equals to 2 times 8 minus 4 times 2 squared. Therefore, 2 times 0 is 0. When x equals to 2 over 3, we can substitute 2 over 3 into fx. f2 over 3 equals to 2 over 3 times 8 minus 4 times 2 over 3 to the power of 2. then we will get 512 over 27. Therefore, the extremum point is 20 and 2 over 3, 512 over 27. From the tables that we draw in previous slide, we can see all the slopes. From there, we can know that the maximum point falls on the border between negative infinity to 2 over 3 and 2 over 3 to 2. From there, we can conclude that the maximum point is 2 over 3 and 512 over 27. And the minimum point falls on the border between the intervals 2 over 3 to 2 and the intervals 2 to infinity. From there, we can conclude that the minimum point is 2, 0. Question 3. Find the intervals where the function is concave up and concave down. Hence, determine the inflection point if any. To find the intervals where the function is concave up and concave down, we must differentiate second time. From the equation f prime x equals to 48x squared minus 128x plus 64, we can differentiate it into f double prime x. First, we bring the power 2 to the front. Then, we minus the power 2 with 1. Next, we will differentiate the negative 128x. We minus the power 1 with 1. Then we will get 0. Then we will get the f double prime x equals to 96x minus 128. Next step, we make the f double prime x equals to 0. Then we will get 96x minus 128 equals to 0. We will get x equals to 4 over 3. From there, we can draw a table consists of two intervals which are negative infinity to 4 over 3 and 4 over 3 to infinity. We will use 0 as the test value for negative infinity to 4 over 3 and 2 as the test value for 4 over 3 to infinity. Then we substitute the test value into the equation of f double prime x. For 0, we will get negative sign, and for 2, we will get positive sign. If the sign is negative, we know that the concavity is sad. And if the sign is positive, then we know that the concavity is mild. From there, we can conclude that the concave up is the interval 4 over 3 to infinity. And the concave down is the interval negative infinity to 4 over 3. To determine the inflection point, we can use the x equals to 4 over 3. Then we substitute 4 over 3 into the fx. Therefore, y equals to f 4 over 3 equals to 4 over 3 times 8 minus 4 times 4 over 3 squared. We will get 256 over 27. From here, we can conclude that the inflection point is 4 over 3 and 256 over 27. The last question is sketch the graph of fx using above information. Firstly, we must write down all the information we get, the maximum point, inflection point, and minimum point. To draw the graph, we must first draw the axis. Then we plot. The last step is to draw the graph line. Don't forget to draw the arrow and also write the graph equation. Now, we're going to check the x-intercepts and y-intercepts. Here, the x-intercept is 0, 0 and 2, 0, which are same as what we get in the first question. And the y-intercept is 0, 0. That is all for this question. I hope that you learned something from this video. If you have anything to ask, you can just comment in the comment section. Thank you so much for watching. Bye!